Okay, so for our final example, example 2, or example 3, we're going to do d squared y over dx squared, and what that means is it's the double derivative. So we're going to do the same thing we were doing with implicit differentiation, and now we're going to do it twice with one kind of little trick. So just like before, I'm going to take the derivative with respect to x of both sides of the equation. Oops, should be of 8. So the derivative of 2x cubed is 6x squared. The derivative of negative 3y squared is negative 6y dy dx equals, and the derivative of a constant is 0. Okay, so once again we are going to solve for dy dx. So I'm going to move this 6x squared over to the other side, leaving me with negative 6y times dy dx equals negative 6x squared. Finally, if I would divide both sides by negative 6y, I would be left with the equation, so I'm going to just draw an arrow over here, of dy dx equals the negative 6 divided by negative 6 would cancel, and x squared over y. Now, this becomes important because now to do the double derivative, I'm just going to do that again. However, now that I have an equation for dy dx, I am going to also be able to substitute in this equation wherever I see a dy dx. Okay, so to take the double derivative, d squared y of dx squared. So I'm now moving on to this part. I'm going to use some quotient rule. So low d high, which is y, times the derivative of the high would just be 2x, minus high d low, and that doesn't give me any problems with the x squared, but the derivative of y is 1 dy dx, so I'm going to write dy dx. Okay, so low d high minus high d low, and then square the bottom, and away we go. And now what I'm going to be able to do is, because already in this part of the problem I found an equation for dy dx, is I can sub out this dy dx that I've just highlighted and replace it with an x squared over y. So I'm going to do that. So on top I have 2xy minus x squared times x squared over y, all over y squared. And now let's simplify that. So I'm going to do a couple things here. I am going to, first of all, rewrite this divided by y squared on the bottom as times 1 over y squared. And then I'm going to write this as one expression. So I have 2xy minus x to the 4th over y. This is just the numerator now. And I'm going to think of this as multiplying by 1 over y squared. So when I distribute that 1 over y squared, what happens then is that I have a y on top and bottom that will cancel. So I'll be left with then 2x over y when I multiply those together. And when I multiply these two terms together, I'm going to have minus x to the 4th over y cubed. And this would be my equation for d squared y dx squared, the double derivative.